Okay, we're finding the area of this figure. I sketched on number 7 a little bit of, there's a polygon up there that I'm gonna say that it's a decagon. It doesn't have the proper number of sides, but we're gonna say it's a decagon because we're just essentially gonna take this pink triangle that I've drawn and we're gonna examine that piece of it. Okay, like that. Okay, and in fact, let's draw an apothem down here like that, because we'll eventually be examining that triangle like this. Okay. Um, so first things first, what would be the measure of? Actually, let me erase this for now. And let's just draw the pink triangle. Okay. Um, what would be that central angle? Well, if you split that thing up into 10 equal parts, because it's a decagon, you have 360 degrees divided up into 10 equal parts, and you have in there then 36-degree angle. Okay? And we've got a side length of 4. They're telling us that we've got a side length of 4 down here. So now if we were to drop this apothem, we would get a resulting triangle that is 18 degrees and had a side length of 2 because you split that actual side in half. Okay. Now, in order to calculate this out, we need to figure out what the apothem is. And so how do we do it? Well, we don't actually have some special triangle, so we need to just use trigonometry. So we're going to say, we'll call this green side, the apothem, we'll call it x. And compared to the 18-degree angle, which two sides are we dealing with? We're dealing with the opposite and the adjacent. Okay, you would say, for opposite and adjacent, that's tangent. So the tangent of 18 degrees equals the opposite side 2 over the adjacent side x. And when we switch their positions, remember we have this rule in rewriting these will switch position to isolate x. And we've got x, the apothem length, is equal to 2 divided by tangent of 18 degrees. Okay? So then, if we know the apothem and we can figure out the perimeter, which we can, we have a side length of 4 and it's a decagon, there's 10 sides. So we can say, okay, then our formula which says the area of this or any polygon is equal to 1/2 the apothem times the perimeter. And we know that the apothem is equal to 2 divided by tangent of 18. And we have a perimeter of 4 yards a side times 10 sides is 40. Okay, so in the course of our calculations, we can say 1/2 of 40 is 20. So we're really doing 20 times 2 divided by tangent of 18. And if we calculate that, and let me just grab my calculator over here. Oops. Thanks for your patience. Let's say 2 divided by tangent of 18 times 20. We get 123.107 or approximately 123.1 yards squared. For number 9, I've cut that same little kind of dummy image of a polygon over there. This is a 9-sided polygon and it's got a radius of 7. So, hey, look at this. If we were going to draw that triangle in there, it looks like this. Okay? And forget about the apothem because we can actually figure out what this angle is. I'll show you what I'm getting at in a second. This is the radius is 7 inches, and this is also 7 inches. And the angle that's in between them, right here, the included angle is, well, 360 divided by 9, and that's 40 degrees. Okay? Because for full rotation of 360 degrees around the center, there's going to be 9 equal angles, each of 40, to make the 360. So now we know that. We have, and in this lesson, we learned a special formula, which is this. Special formula is this. The area of one of the small triangles is equal to 1/2 the side length, 7, times the other side length, 7, times the sine of the included angle, sine of 40. Okay? That is a special way of finding the area of a triangle that's not a 90-degree angle. You can just do the length, and it works for a 90-degree angle too, but you can take the length of the two sides multiplied by the sine of the included angle times 1/2, and you will get it. So here we're going to do it on the calculator. Let's see, 0.5 or 1/2 times 7 times sine of 40 degrees. And we get 15.748 something something. Before I round it off, you got to remember, if this is a nonagon, I found the area of one of those triangles. And if you look over here on my little dummy triangle here, when I say W, what I mean is like it's a stunt thing that I'm going to use for all examples, even though it's not perfectly matched to every example. But that little triangle is the area that we found, which, by the way, let me write it in, approximately equal to 15.748 29654. Why am I not rounding it off? Because I need to multiply it first. There's 9 of those little triangles in the large polygon. So if I take that number and I do times 9, I will get the larger area of the entire nonagon is approximately 141.73, so 0.7, and it is inches squared. Good. That's what it has as the answer in the book. Okay, so if you know the radius, you can use the radius twice as the two side lengths, and then you calculate the included angle by figuring out how many equal angles are coming from the center. And just to be clear, the formula is the area of one triangle is equal to 1/2. The way that you'll see it written is 1/2 BC times sine A, where A is an angle and B and C are the sides that make that angle. Okay? Part of the lesson. So let's keep going. Again, we've got a radius, so this is great. We can take the radius and we can say, if we took our, let me grab another screenshot of this little, oops. This right here, okay. The two pink sides will be the radii. They'll each measure 2, and I'll draw that triangle out. These each are 2 millimeters, and the included angle is whatever you get when you divide 360 by 20. And when you divide 360 by 20, which is how many sides that polygon has, we get 18. Okay, so this angle right here is 18 degrees. So then we can use that formula, which is area equals 1/2 BC sine A, and say, okay, that means 1/2 2 millimeters times 2 millimeters times sine of 18 degrees. And if I wanted to find the area of the whole thing straight away, instead of just leaving it as that for area of one of the triangles, I could say the entire area would be that times, I'll do it up here as the formula, times the number of sides. And what is the number of sides? In our case, the number of sides is 20. So we could type that whole thing in straight away, find that out. So we've got 1/2 times 2 times 2 times sine of 18, close those parentheses, times 20. And we get, for number 11, 12.36, or approximately 12.4 millimeters squared for number 11. Okay? You got to be comfortable with the ideas generally of what we're doing, because if you're really lost on these concepts, then some of the stuff I'm saying will be going too fast for you. Okay? Now, let's keep going. Okay, we've got a 15-gon with a perimeter of 180. So if we wanted to know what the side measure was, and we do, just to be able to find the apothem. Okay, I'm going to take this same little sketch drawing that I made, and I'm going to plop it over here, and I'm going to say I'm going to make first of all, I'm going to do 180 divided by 15. And what that's going to find for us is it's going to find the length of a side. So we've got each side equaling 12 centimeters, because if we did 12 centimeters per side times 15 sides, we'd find the perimeter of 180. Okay, so we also now need to take 360, which is the total number of degrees of rotation from around the center, and we need to say, well, it's a 15-gon, so I'm going to divide that by 15 as well to find out how much each central angle is. So 360 divided by 15 is 24 degrees, because this is degrees. Okay, so between those two pink radii, we're going to get 24 degrees. So if we actually then drew this triangle of the apothem and one side, I'm sorry, and the radii and the base there like that, we would get a right angle here. Okay, but remember, each pink line, each two radii like that will form 24-degree angles. So between the pink and the green, we will get 12 degrees as a measure. So I'm going to write that in here. This angle measures 12 degrees. Okay? And remember, we found that there was 12 centimeters per side, but then the apothem cut that side in half. So instead of 12 centimeters here on the bottom, we've got a 6 centimeter length there. So why are we doing this? Because we need to find the apothem. Because we can use the formula, the area of a polygon is equal to 1/2 times the apothem times the perimeter. And we already know the perimeter. They told us it's 180. But we need to find the apothem. Okay, so I'm going to erase all this stuff over here on the side. We got the measures that we needed out of this. So what do we have now? Well, we need to calculate which two sides are we dealing with. We're trying to find x, the green side. And for the 12-degree angle, we've got the opposite 6 and the adjacent x. So we're going to say tangent of 12 degrees equals opposite side 6 over adjacent side x. And when we isolate x, we get x equals 6 times the tangent of 12 degrees. Okay, that's the apothem. So I'm going to take that and use that as. And the program is glitching out a little bit, so I'm going to just pause it and I'm going to rearrange everything to make space, and I'll show you what I've got in a minute. Okay, I think I've got this sorted out. Sorry about that. So what we've got here then is that 6 divided by tangent of 12 degrees is what we just figured out the green apothem length is. So now the orange formula, a equals 1/2 a times p, is going to give us the area of the entire polygon. So we do 1/2 times 6/10, 12 times the perimeter, which is, we were told, is 180. And so times 180. Okay? And then the area will be approximately equal to 0.5, turn this on, 0.5 times parentheses 6 divided by tan of 12, close parentheses, times 180. And we get 2,540.5 approximately. 2,540.5 centimeters squared. And let me just check my answer against the book. 1 second, sorry about this. Working lots of angles at once. 2540.5 centimeters squared. That's exactly what we got. And so there it is. I'm sorry this video took a while. This was a little glitchy for me today. But anyway, let's box those final answers out so you can see them. And we're done.